Okay, welcome to this video, and in today's video we are extending our series of Rust, of course, but also we are talking more about traits in Rust. We had the first video, and if you haven't watched that, please check the playlist. And yeah, let's look at traits in depth. And we talked about traits as a way of sharing behavior of types, how types can exhibit different behavior. So we want to extend this idea and see. But first, we are creating a new Cargo project. We have looked at Cargo in our previous videos, but Cargo is mainly a package manager in Rust. So we are saying Cargo new, and we name the project that we want, and we are calling this project Super Player. Now we are no longer writing. So here we have a new project. And this project is having some files that we are going to briefly talk about, but let me first go into the Super Player, and I want to open it in VS Code. It has opened this side. Okay, this font is too small, and I want to make it a little bit bigger. I hope that is better. So we have a folder here called the source folder, which contains the main Rust file, sort of like the entry point of our project. And we have the git-ignore, of course, you know what the git-ignore is. And then we have the cargo.toml file. We might not talk about much or use this file in today's video, but what you need to know, we put our dependencies here, all the dependencies that we want. And these dependencies are crates that we will see more in upcoming tutorials. But what you need to focus on is this main file today. So this is like the entry point of a Rust project with Cargo, or a Cargo project. So what do we want to build today? We want to demonstrate traits using the concept of an audio player and a video player. And which trait do we want to demonstrate today? We want to demonstrate two traits. That within the audio and video, there could be shared behavior, and this shared behavior could be play and pause. Both of those players, if they're playing audio and video, you need to create a functionality of playing and pausing. So how can we represent these players? One, we can use the common or the most common way by using unit structs. And structs are so precious in Rust, one of the common ways of representing data. So our audio we'll choose a string, and our video we'll choose a string to represent. This is string. Okay, so from there we want to implement or talk about this trait. And this trait, the best way to represent this trait, we are going to create a new file, and we are going to name this file media.rust. And we're sort of like wanting to separate concerns here. And how do we declare traits? We've talked about that in our previous video. Trait, and we are calling this trait playable, both audio and video. We want to play them because it's a player anyway. So you can call this trait anything, playing, player, not strictly that we must call it playable. So it's just the name of that trait. But the idea is we want to play the video and audio. So the trait will take on these behaviors that we want to represent, and we've talked about them, and we will implement them through these methods within. So we want to implement the behavior of play, like real playing, and playing will take on, let me first represent it. Okay, self. And at this level, we don't have to implement fully this method, but we define it. And then we implement another, which is pause, and we assign it as a reference self. Now, I want to talk a little bit about these method signatures to a symbol self. And if you notice the signature of play, it takes a reference, and of course it doesn't have a body, and it ends with a semicolon. What do we need to know about self? Self is just a type. It's a type alias, or a representation of self. So this one is a representation of this with capital. Which self am I talking about? It's an alias for self, and literally this is referring to a type on which the trait is going to be implemented. So basically that's what is happening here. So it's an alias. I want to talk about this. Self is an alias for self. So another thing that we can note here, we have implemented this, we have defined these methods, the play and pause, which are the behaviors that we are talking about, but we have not defined them. Now, we have two options. We can define these behaviors here, and we will see in the future that we have the option of overriding them. Now, what do you want to define in pause? Well, you want to pause the video, but because we are not building a real world video or audio player, we will just print something to the screen, and we are saying, so paused. You don't have to include that exclamation mark. Just included it. So don't forget the semicolons there. So we've defined this trait. I don't know why this is unsaved, but it's okay. So we've defined the trait playable with the behaviors. Now we want to come back to the main source file, and what we want to do here is we now want to implement the preceding player trait on audio and video types. So how do we do that? We use this famous implementation keyword, impl playable or audio. Well, you can begin with video, but doesn't matter. For the function or the method that you want to extend here, remember we had the play, and the pause in the playable trait. So we want to implement them in the implementation block. So implement play, and we still put this signature solve, and we want to implement by printing something to the screen. Yeah, we don't need to get sophisticated here. Now playing that particular song, whichever song, and we are saying solve to 0. So whichever song is in the queue, whatever first song in the queue is what we are playing. Yeah, we might not, or we might delay implementing the pause or the video. Either way, the pause is already implemented, so we don't necessarily have to implement it again. If you implement it again, it is still okay, and that will be overriding it here, and we will see that in a bit. But first, let's implement playable or video. So like that. So we want to implement this trait playable when it comes to video, and you can see how this trait is, or this behavior is being used by both entities or both types, so to say. So we have the method play, literally the same thing, and we're saying solve. We will still do print the same thing on the screen, and we're saying now playing whichever song or video that is in the queue. Okay, and for this we can implement the pause function, pause, and we are saying solve, and we are saying print. We can customize this to video. Okay, the video has been paused, people are not happy, and we can go to our main function and paused, try to print things to the screen. So define some variables here which are not mutable. Of course, we don't need mutable variables for now. We'll define the audio, and this could be anything. Which song can we think about? We can positions. That's MP3. I don't know who sang that song. I think it is Ariana Grande. Yeah. So positions, it's a string, so we need to pass it to convert it to the string class by using toString here, and we can define a video, which is video, and we are saying this is video. Could that be okay, Trump victory speech? We're doing the same thing, and this can be video format. We can have MP4, MKV, anything, .2 string. Okay, now we have to test out the pausing and the play. So we can do audio.play, okay, and then video.play. So what do you think is going to happen here? We have the unit structs representing the entity types that we want to implement the behaviors on, and we have implemented the trait playable from here, and it looks like we are good to go. But I don't want to disappoint you, but I will. This is not going to run, and we will see why. So to run Project C under cargo, we can call cargo run or cargo build. It will build if it's not built, but I don't want to pass there. And voila, we are having errors here, and we're seeing that cannot find the trait playable in this scope, meaning that trait is not accessible. Impl not find in this scope. So we're having access issues here. And yes, I did that on purpose. So for you to access the playable traits, traits are private by default, and to make them public, you have to declare them public by using the pub keyword. So there it makes the trait accessible. But shall we have access to it again? let's see. Still the same problem. Why? Yes, it is public, but there is no way the main or the entry point is getting to know about the media or the playable trait that we've defined. So how do we do that? How do we solve the problem? By using the module keyword or mod, and we're saying that we have a module called media. But that's not enough, and you want to use the use keyword. We want to use the media file, and in there we want to find the media module, we want to find the playable trait. We should be good to go from here. Okay, so we run again, and voila, we have some warnings, but at least we ran. We are saying that function pause players is an area. Did I do that? Okay, that's okay. Yes, we'll look at that later. But at least we are playing the positions video and the positions audio, and the Trump victory speech. They're all playing. Someone is wondering if we've not tested the pause. Let's try to pause the video. Sorry, the audio maybe. But we haven't implemented audio video.pause. Okay, we want to do that. Remember, we have implemented pause for the video, so we expect video paused. And let's also do for audio. Let's pause all of them. So shall we pause the audio? Because we haven't implemented the pause method in audio. But let's see what happens. Ooh, look what we've got here. We have been able to pause the video paused, and we have the audio, and we have paused the video. Why is audio paused? Because we've implemented the pause method in the trait definition. So that's why we can have access to it. But we've said that we can override the method defined in the trait playable, and therefore we can override the pause here, and this means we pass the method signature and that reference, and we can say, or we can print something to the screen and say audio paused maybe. So if we run again, this is the function the method that we expect to be called, other than the one originally defined here. So sorry about that. So we run again, and voila. So we see that we can override those methods. So that's all I had for you guys in this video. In the next video, we'll be looking at inheritance of these traits. If you liked the video, please don't forget to leave a like, a comment, and subscribe to the channel. See you in the next video.